3,000 times 2x plus 3 to the negative 1 minus, okay. It's ugly. Granted. 1,500x plus 3,000. 2x plus 3 to the negative 1 minus $1,000. Okay, and this is in dollars. Right. Find the marginal revenue when find the marginal revenue when 100 units are sold. So it's asking us to find marginal revenue when 100 units are sold and interpret. Okay. Well, let's take it term by term by term. The derivative of 1,500x is completely separate from the derivative of this monster, is completely separate from the derivative of minus 1,000. So we always go term by term. Things that are separated by pluses and minuses, we just treat them like separate bits. So let's take the marginal revenue and let's start with this green term here. What is the derivative of 1,500x? 1,500. And then what about this guy? So let's do d out d in. So ignore the junk on the inside. Negative 1 comes down, making this minus 3,000 junk to the negative 2 times the derivative of the inside. So now we peel. Everything inside of the parentheses takes derivative. That's 2. And then the derivative of minus 1,000 is just 0. Okay. How do you guys feel about that one? If I were to really simplify this so that I could do this stuff in my head, which I'm not going to do, but let's say I wanted to simplify it because this just looks awful to me. I would take the 1,500 and drag it along because it's its own term, and I would take the 2 and the negative 3,000 and make them negative 6,000, and then I would divide by 2x plus 3 quantity squared. So all I'm doing is I'm multiplying this 2 and this 3,000 here, and then dropping this downtown. So far, so groovy. I was very proud of myself yesterday when I came up with something. If it crosses the line, it changes the sign, right? So if you drop anything uptown or downtown, you're gonna change the sign of the exponent. So excited about that. I was really happy, Brenda. I really was. I was like, oh, that's really cute. I'm gonna hold on to that one. Good times. Now what do I do?
Plug in 100.
Yeah, plug in 100. Don't overthink it, guys. So marginal revenue at 100 is going to be 1,500 minus 3,000. No, 6,000. The 6,000 divided by, let's see, 203 quantity squared. Right? Isn't that a lot prettier than this mess? So sometimes simplifying it is a self-serving thing. Sometimes you do it just because it's easier to work with. But you could totally plug it into this and you get the same answer, which is what, guys? By the way.
1,499.85 cents.
1499.85? 1499.85. So we're saying the 101st unit will bring in approximately 1,500. Okay. Questions?
So just the one, sorry.
No, go ahead. You and you.
Just
Maria.
the one, because we were doing 100, right?
Yeah.
So just the one, because we're doing marginal revenue, the one will bring us 1,500.
Yeah, the specific one
Just the one.
is the 101st unit. because the 99th unit might bring in a different amount,
Okay.
right? So remember, when we're doing marginals or slopes of any kind, your slope is always rise over run. So my run is always 1. This is actually divided by 1. So we're going from 100 to 101, and we're gonna go up 1499.85. Brenda?
I'm sorry.
Yeah, go for it.
What happened to the X on the 15?
The X where? On the 1500? We took the derivative.
Oh, okay, okay.
Yeah, so I just went term by term. So this derivative is this derivative is this beast, and this went away.
Okay.
Okay?
It's too early.
I know, it's okay. No stress. And I see like a lot of the class is gone. 3, 5, 8, 10, 12, 16, 19, 21, 26 people. So I'm missing like a good third of the class right now. They're going to be very, very sad. They really are going to be very, very sad. Because today we're doing 2 sections, and I'm handing you guys the review for the test. So here we go. That eraser, could you pinch that eraser at me? It's okay, yeah, throw it. Thank you. It's a lot nicer of an eraser. I think somebody's hiding it over there so that they don't have to use like Mr. Shoes Washington Crockerton. Thank you. Okay. All right, guys. Today we're going to learn how to put all of that. Oh, there's 9.6s. Huh, they were here somewhere. Today we're going to learn how to put it all together. So what? The 9.7 is putting it all together. And we skipped 9.8, save that for chapter 10 because they go together. I don't know why they organized the textbook this way, but whatever, we're doing it this way. And 9.9 is applications. So if you thought you were gonna get away from the applications, they're never going away. The end of each chapter is an applications set. Just to hammer it home, because you know that's what we're here to do, right? Is to relate it to business. So, putting it all together. Let's talk about the things we've learned so far. We've learned that a basic function becomes an x to the n minus 1, right? We've learned that. We've also learned that when we have a function that is a product, its derivative uses the product rule. We've also learned that when a function is a quotient, we can take the quotient rule. U prime v minus v prime over v squared. And then the last thing we picked up was d out dn. So if we have a function that is some function to a power, we take the derivative of the outside, f prime of x is going to be nu to the n minus 1. That's the derivative of the outside. And then the derivative of the inside is u prime. So that's kind of a new way of looking at that. And it looks a lot like this guy, except now we have 2 nested functions, okay? Where nu n minus 1 is d out, and u prime is dn. So we're literally doing d out dn. I talked to you guys about d out dn before, right?
Yes.
Okay. All right. So we're going to take all those and we're going to smash them together. The first trick when we smash them all together is to figure out what exactly the global function is. And so for this, it sounds crazy, but squint. Get the board fuzzy until you only see the details, or you don't see the details, you only see the big picture, okay? So bear with me. Let's try this guy. know you guys see the quotient, but globally, the outermost function, is that a product? A power? A quotient? Or what I just call a straight derivative, which is the first thing we learned, the shortcut. Straight derivative. You sure? I heard it. Power. It's a power rule. Why is that? The power rule is d out dn. We have a nested function here, guys. We have, on the outside, we have some jump to the 8th power, and on the inside, we have a quotient. Good. So I would say, globally, this is a power, and locally, this is a quotient, okay? So we start on the outside, globally. That's what I mean by globally, is the outermost function. And then we start peeling. So the derivative here, while it may look complicated right now, is actually fairly straightforward. D out is D out. What's the derivative of the outside? 8 times jump, right? That never changed. X cubed plus 6x to the what power?
7.
That's D out. Okay, so let's hang here for a second. That's the derivative of the outermost function. Is everyone okay with that? Now, when we peel the outermost function, what are we left with? That's gonna tell us what we're gonna do to take the d in. Our derivative of our inside, we're gonna use the quotient rule. You guys cool with this? Okay, so now, what's d in gonna be? U prime times v. Don't worry, I'll label all my parts. Minus u times v prime over v squared. So I'm going to call this dn, this entire massive. So we still have the derivative of the outside times the derivative of the inside. And the derivative of the inside was u prime v minus u v prime over v squared. What do you guys think? Damn. If I had thrown this at you on day 1, you would have thrown up your hands, thrown your pencils at me, and walked out. But look at you now.
We're better than that, yes.
Look at you now. No, it's not about that. Like, it's this contract between two people, between you and between me, where I don't throw you in the deep end. I take you through it incrementally, and you've learned to swim, and you didn't even know it yet. That's the contract. You guys can do massively complicated functions in your heads now, with just a little bit of guidance from these formulas. Do you guys have questions? What's the hardest part here? Remembering which piece you're on, deciding what the global and the local behaviors are. We're gonna get a crap ton of practice today, okay? So take your photos if you need to. I'm gonna erase this guy in about 10 seconds. Yeah. Exactly. I love engineering paper. No, seriously, I really do. Yeah, it's all I worked on when I was in school. about this one? Brenda, that's a what?
Product?
That's a product globally. Locally, we have a what on V? Power. Okay, so globally, the definition of our entire derivative is gonna be based on product rule. Right? And then locally, on V, we have a power. So when we go to take the derivative of V, we're gonna have to do d out dn, because that's what kind of function we have on it. You guys ready? I'm gonna identify all my parts, because that's what we do, because with a product, we do u prime v plus u v prime. So I'm gonna identify everything. So here's my u, and here's my v. Well, if that's the case, what's u prime? 4 minus 20x. And what's v prime gonna be? Start with the outside function. Resist the urge to touch the junk until you've peeled off a layer. 4 junk, right? To the what power? 30. Now, what's the derivative of the inside?
21.
Nice. So what we're doing is we're peeling this into bite-sized chunks so that we don't lose our minds on these functions. Now we plug it all in. You guys ready? So f prime is going to use the product rule. So u prime comes first. 4 minus 20x times v, which was 3x to the 7 plus 19, all to the 4th power, plus u,
You mean third power?
4th power, u prime times v. Yeah. 4x minus 10x squared plus 8 times v prime, which is 4, 3x to the 7 plus 19 to the 3rd times 21x to the 6th. So let me label all my bits again. Gesundheit. Here's u prime, here's v, here's u, and here's v prime. Nothing has changed. We're just adding that extra little bitty layer of sophistication. You guys can expect one problem, at most two, to look like this on the exam. At most one, actually, I would say safely. But look for a layered problem on the exam, where you use multiple processes to take the derivative. Okay? Talk to me.
We have to simplify.
God, no. No, I'm gonna be checking it off as I go to see that you did all the bits. Make my life easy and don't simplify it, okay? I mean, if you want to, you can. But here's the catch. I'm gonna remind you guys again. If you are not told to simplify and you try to simplify, well and good. But if you get your simplification wrong, I gotta dock you, because you did wrong math on a test. So stop while you're ahead. Get it to the point where you've written down your derivative and call it a day, unless I explicitly tell you to simplify. Groovy? Okay.
And then this type of problem is called what again?
There's really no, it's just a more complicated version of all of these things that we've done together. I just call these the global local functions, but that's my name for them.
Okay.
Yeah, I don't have a name for them. They're just more complex, that's all. You guys wanna see another? Okay. All right.
There's a choice.
Yeah, you have a choice. move on to the application problem, so we're gonna do that eventually, but right now, let's do this. You guys are really subdued today, what's going on? Did you get some bad news? You guys okay? Is everyone all right? Do you want me to start throwing markers at you? Let's start with you. Okay, I'm not gonna throw markers at anyone. G of x equals the square root. Yeah, the square root of 4 plus 8x squared times 3 minus 6x. How do you make it pretty? Get rid of the radical. Everything under the radical has a power, doesn't it? So we can wrap that entire thing, whatever it is, and give it a power. And then this is a square root. So what's the power gonna be when I make it pretty? Yeah, 1/2. Here we go. 4 plus 8x squared. 3 minus 6x to the 1/2. Globally, is this a product, a power, or a quotient? We already know it's not a straight, easy, like, one-step derivative. It's a power, yeah, good. Locally, is this a product, power, or quotient? Product. So globally, we're gonna do d out dn. Globally, it's a power. And so we'll do d out dn as our process. And then locally, inside, it's a product. And so dn is gonna literally equal u prime v plus u v prime. So let's start identifying our bits. Well, let's take the derivative first, and then we'll identify all of our bits. So g prime, let's do the outside. Don't touch the junk, one layer at a time, guys. What's the derivative of the outside? 1/2 junk. To the what power?
-1/2.
Good, okay, that's D out. I'm awake. No, seriously, my colleague came in and scared me with the copier, and I nearly like broke his nose with my elbow. He came up behind me, he's like, Rod, I'm like, oh Jesus, it's you. He's like, please don't do that. I'm gonna kill you next time. Not good. So he was like, what the fuck? Don't scare me. I don't like it. My husband knows better. When I'm like chopping vegetables and he's in the room, he calls out, he's like, I'm here, because he doesn't want me to get scared and stab him. That's kind of a thing. Great, so now let's do the derivative of the inside, which is gonna be u prime v plus uv prime. So u prime is gonna be what? Yeah, and v plus u times v prime. Finish my brackets. So I'm gonna color coordinate these. So globally, I'm gonna call d out dn. Here's d out. And here's dn. And locally, I did u prime v plus uv prime. U prime v plus u v prime. What's the hardest part for you guys? Everyone's got a different thing that they struggle with. So what's gonna be your thing? What's gonna be the thing that you're gonna have to work on the most on these?
Getting the numbers right in front.
getting the numbers right in product?
Yeah, it's just like writing them all down, right?
Yep. Follow along with your finger if you have to. I do, no shame. Seriously, I'm like, okay, I'm on this part, and I'm on this part, and I'm on this part. If that's what you need to do, that's what you need to do. It's okay. Seriously. What else?
Remembering the brackets.
Remembering brackets. You can use parentheses, totally okay. But brackets help me remember which part I'm working on. So remembering the brackets is gonna be a struggle for you. Yeah, because tell me what's wrong with this picture, guys. If I don't put these brackets in, how is that incorrect? What is this being multiplied by now? Just these first two terms, right? And we want the whole thing to be multiplied. So yeah, maybe put something in bright puffy pink letters on your cheat sheet about remembering to bracket all of your pieces. Maybe that'll help remind you, I don't know. Yeah, but little reminders like that can be certainly useful. What else? Identifying global and local from the beginning. Okay, so yeah.
I put a little dot just for myself after that app. Then I put the bracket and that tells me, yeah, that is always like.
That you're multiplying them together, that can be useful. As far as recognizing the one, let's say on the test you're stressed and you're like, I have no fucking idea what this is. It's like I've never seen it before. Who's sitting right here? Am I just for pretty? Nah. Thank you. Nah, I'm not. Come talk to me. I'll give you a nudge in the right direction, okay? I'll remember and remind you and hopefully like bring your mind towards what you need to go towards. I'm always here for nudges. Use me, guys. In the real world, we don't work in vacuums and we don't work off of cheat sheets. We work with collaboration, which is why your third test is a group test. You guys forgot that, didn't you?
Yeah.
Group tests are awesome. They're so much fun. Yeah.
We can bring a piece of paper.
Yeah.
With like stuff.
8.5 by 11, single-sided, handwritten to be turned in with your exam. Okay? That means a full sheet of paper, handwritten, not shrunken. Shrinking tells you nothing. Handwrite it. That's how I force you to review. It's my sneaky little way of making you do that. And yeah, so we should be good. Yeah, start now, because your test is a week away.
What happens? It's 2 weeks from Tuesday.
Maybe I was looking at the wrong one. Oh, wait, this is Monday, Wednesdays. Maybe I got all the stuff done early. That'd be nice. Oh, it's the 24th? Hot
Yeah,
damn.
I think I understand the like 20. I sorted.
Oh, yeah.
Barely.
Kind of scared
me.
I'll be giving you your handout early anyway, to start your review. Because this is the last homework of this is the last homework of the section. Because 9.8 and 10.1 are on test 2. So I'll still give you guys your review checklist today. That makes sense too. Okay,
I have a question.
I have an answer.
Okay.
Yeah.
I'm confused.
Yeah.
So I understand the global part where you identify the first step, but
The
then
outermost function.
Yes, and then the second step, I'm completely lost.
Okay, so
like
DN is where you're lost.
Yes.
Okay, so let me walk you through this using an eraser.
Okay.
Haha. So you're okay with this being a power?
Yes.
Okay,
'Cause
so
you
start with the outermost function, D out. You can get this far, right?
Mhm.
Now peel. What's left? A product. So you're going to use the product rule to take the derivative.
Okay.
You with me?
Yes.
So peeling literally means sloughing off that outer layer. So once you've taken the derivative of the outer layer, away it goes. And you start using the innermost stuff to define what you're going to do.
Okay.
Okay? So because it is a power, we have to do D out, D in, but D in has its own process. The internal function was a product, so we have to do product on it. So I'm gonna do this trick one more time with another function.
Yes.
See how you do with it.
That makes more sense.
Gesundheit. Godzilla. Sláinte. Wait, you say that when you're drinking, not when you're sneezing. It means the same thing. Salud. Votre santé. How many more can I do? All right. How about this one?
How do you know if it's a power what it has before or what?
Globally, it's a quotient. Why is that, Brenda? Memo.
The vision line.
Yeah, that's the thing that sticks out the most. So if I had done this, that would make it a what? That would make it a power, because the power would be tied to the whole thing. But that power up there, that 5, is only tied to the numerator. Okay. So now, let's identify our parts. Here's U, here's V. U prime is what kind of process, guys? Power rule. So now, what's the derivative of the outside?
No, 5.
Junk. To the 4th. Now, peel that off. Don't worry, I'll rewrite it in a second. You've done the outside. What's the derivative of the inside? 3. Good. That's U prime. Okay. Now let's do V prime. That's a straight derivative. That's what I mean by straight derivative. There's no extra stuff that has to happen. We just go through. So what's the derivative?
6 plus 8.
Plus 8. Okay. So do we have all of our parts for a quotient? Now we plug and shove. Guys ready? H prime is going to be U prime, which was, I'll just leave it all in as I wrote it. That's U prime times V minus U times V prime all over V squared. And here are my parts. This is U prime. This is V. Here's U. Here's V prime. Here's V squared. Does peeling help you, Brenda? Okay. Peeling's good. Yeah. Well, you could if you wanted to. You mean like this? You could. Won't change anything. Because this is all multiplied, and then it's multiplied again. So even without the bracket, you still have multiplication between those two bits. Yeah. But yeah, totally fine. If it helps you to define the parts, by all means, do it. It won't hurt. An excess of brackets is not a bad thing. A lack of brackets can be a very bad thing. Okay. Talk to me, guys. What do you see? Give me a shaker if you're kind of there. Okay? Give me a thumb if you've got it. If you're solid. Okay. Awesome. Awesome. Okay. All right. You want to see one more? All right. Let's just do one more. And then we'll tackle the application problems. And hopefully, I'll be able to give you guys a little time to work on these as a group. So you guys have a little time to do these together. Yeah, I like that. Outside it's a power. Inside it's a quotient. Awesome. So because globally it's a power, our global behavior is going to be d out to it. Okay. And then locally, it's a quotient. So dn will be u prime v minus u v prime over x squared. Is it pretty? Can we make it pretty? Okay. How do we make it pretty?
All that. Yeah.
Good. 3x minus 10 over 2x plus 6 to the 1/4. Okay. So let's start with the derivative of the outside. So what do you guys think the derivative of the outside is going to look like?
So 1/4.
Yeah, 1/4. Junk, which is 3x minus 10 over 2x plus 6. And then your new exponent is going to be,
Minus 5.
careful,
No, minus 2.
minus
No,
3/4. What's 1 minus 4 saying? Good. Negative 3. Awesome. Okay, so that's d out. Now Brenda, peel.
Okay.
Took the derivative of that power. Now what's left? So now we do the derivative of the quotient.
So it's u prime and v prime.
Good. Awesome. So the rest of this becomes u prime times v minus u times v prime all over v squared. And you're done. Oh, it's bestial, no lie about it. But it's edible if you take it one bit at a time. Okay? Nobody eats a whole steak at once, unless, you know, you're like starving. And even then, take your time, guys, chew your food. Don't choke. Take this one bite at a time. Don't try to choke. Okay? How do you feel? You want to give these a shot? Let's spend a few minutes on working on these. And then we'll tackle application problems in a sec. I know you're not quiet. I'm not. These guys, you okay? You good? You good? Awesome. And you guys, are quiet good? You're not so quiet, but it's okay. Yeah, I know, I need that. You guys need that. Every question that you guys ask is a question somebody's thinking that somebody wants to know the answer to. How are these handouts working for you guys? Are they useful?
Yes.
Okay. They need to be bigger, smaller, more, little, less? They're good? Little more guidance, a little less? Okay. Well, let me know if there's something I can do to improve them. Because I build them for you guys, so you gotta tell me what you need. The context, or the basics of business in the context of this class is the very first handout I gave you, which you should be thoroughly familiar with, I hope. It's the very first thing. I may have a couple of extras for those of you sneakers that have lost it. I may have a couple of extras. Like, I'm gonna save literally 2 for this class and 2 for the other class. So I saw your hand, and who else? Hurry up.
No, I do have it.
Okay. That one, yeah, you've got it. Okay, so I want you guys to have that on hand, because you're gonna be reading it. Maybe not today, but you're gonna need it. Yes. It's basic knowledge that you're gonna need for the exam, so yeah, for sure, you're gonna want it. There's so many handouts, yeah, so many papers, I know you guys. You need to put this. Okay. Okay, so the basics of business in the context of this class, the first handout I gave you, you guys probably didn't understand what marginal profit equals 0 meant, but now you do. That's the place where the slope is 0. That's where profit maximizes, okay? So if I ask you to maximize profit, what are you gonna do? You're gonna take the derivative, you're gonna set it equal to, you want a slope of 0, and you're gonna solve for x, right? And that'll give you production that maximizes profit, or how many things you need to build and sell in order to maximize profit, right? But how do you get the corresponding profit that goes along with it? That's technically a y value, isn't it? So where do you go to get y values? Not the derivative, the original function, which would be a profit function. Does that make sense? So now we're incorporating concepts that we've learned all semester long, which by the way is a quarter over as of today. Congratulations. You guys have made it this far. Did you die? No, okay. I saw a hand. Is that a hand? Okay. All right. If you flip it in, you're gonna see the same thing for revenue. How do you maximize revenue? Talk me through it. It's where the slope is 0. So we take the, set it equal to, solve for x, and then we take that x value, which is the production level that maximizes revenue, and we shove it back into revenue, our original function, to get max revenue. You guys see the procedure? It's the exact same thing we've done before. We're just calling it names instead of numbers now. Ruby? Cost. Flip it over. Cost starts at a certain point and it grows from there. That certain point where production is 0 is called your fixed costs. We don't start with 0 cost. We start with fixed costs. There's always some positive cost, even if you're not making anything. What can those costs be? Any ideas? Electricity, yeah. Rent, insurance. How about your salaried employees? They get paid whether you make anything or not, right? So those all go into your fixed costs. So far, so groovy. Okay. So we already know that average cost is cost divided by X. We've talked about that. Flip back over to revenue for a second. And what's that box down there halfway down the page say? Yeah, revenue equals price times quantity. Think about it this way. If I sell 200 $4 toothbrushes, how much money did I bring in? 800 bucks. I literally set a $4 price and I sold 200 of them. That's my revenue. It's literally price times quantity. If you can't remember this, put it on your cheat sheet in big puffy pink letters with glitter, because you will need this all semester long, okay? And lastly, the way these work together is if you were to graph revenue and cost, and you find the difference between them at any given X, so think of a vertical slice. This is kind of like the function at, right? If revenue is bigger than cost, your profit is positive. And if your costs are bigger than the money you're bringing in, your profit is negative. So do you see this X at break even right here? Drop it down to the profit function and you can see where that goes from negative profit to positive profit. It's the exact same point. So the point where revenue crosses cost is the point where revenue equals cost and your profit is 0. Does that make sense? Okay, so these are just basic function stuff, right? Cost is greater than revenue when your profit is negative. Revenue is greater than cost when your profit is positive, okay? So where would max profit be? Yeah, it would be where profit slope is 0, right? So marginal profit equals 0. But up here, it's where the distance is greatest between them and revenue's on top. That's the other part of it. Revenue has to be on top, it has to be a positive profit, and the distance has to be the greatest. So imagine dragging a positive line across this function, and wherever the distance is greatest before it starts shrinking again, that's your maximum profit point. So if you draw that all the way down, you would see the same thing on the resultant profit function. Do you guys see that? Profit starts growing, starts growing, starts growing, starts shrinking, starts shrinking, starts shrinking as we go along this space between revenue and cost, okay? So I need you guys to understand those basic concepts before we move forward. Go to your applications handout. And you guys are gonna see it's all there. To maximize profit or revenue or minimize cost. Look at the steps. What's the first one? Take the derivative, which we already knew how to do, and then set it equal to 0, which we already knew we were gonna do. Solve for the X value that gives you 0 slope. That's the production level that maximizes profit or revenue or minimizes cost. And then you plug your X value back into your original function to get the corresponding maximum profit, minimum average cost, maximum revenue, et cetera, et cetera, et cetera. So it's the exact same procedure that we just talked through that made sense. Now we're doing it using steps. Groovy. So, flip it over. Let's do a problem together. So you guys can walk this along with me. Suppose you build junk muffins. I have no idea what they are. They're probably like muffins with every possible fruit stuffed in them, whatever. You make junk muffins. Or they just could be cars, I don't know. Whatever you want to call a junk muffin, it's a junk muffin. Revenue, that's an expensive friggin' muffin, $46. Wow, 46X. What?
They're made out of gold.
Yeah, seriously, they must be made out of gold.
And then include free dentures.
Yeah, free dentures, that's good. So cost is 100 plus 30X plus 1/10X squared. Find the profit function. What is profit, guys?
Revenue.
Yeah, profit is revenue minus cost. Revenue minus cost. And the biggest mistake, you guys, is you don't parenthesize your cost. So tell me what's wrong with this. every semester, and it makes me cringe. What's wrong with that picture?
It's only minusing the 100, not the whole
It's
30.
only subtracting the 100. So if I subtract all of cost, my whole sign is gonna change. Minus 100, minus 30x, minus 110x squared. You guys with me? Every sign and cost must change. So that's your profit. That was easy. Find profit when 100 junk muffins are sold. What do I do? Did it ask for marginal profit? No, RTFQ. Read the full question. So it asked for profit. So where are you gonna plug 100 in?
And the X.
The profit function, right? If it wants profit, you go to the profit function. If it wants slope, you go to the derivative. So profit at 100 is gonna be 4,600 minus 100 minus, let's see, 3,000 minus 1/10 of 10,000. So that's 4,500, 1,500, 1,000 is 500. Okay. So this is about R-ing the FQ and knowing what to do with it. All right? These applications aren't as scary as you think, but you gotta read each piece carefully and decide what it's asking you to do, what you're gonna plug in where, and how you're gonna achieve your goal. Ruby? Everyone cool with part B? What's part C? Find marginal profit. What is marginal profit? No.
Extra unit.
Well, technically, it's the derivative, right? Plug an X value inside and you get the profit off of one additional unit from whatever reference unit you're starting with, right? So yes, but no. So what's my derivative? Mm-hmm. How'd I get that?
What did you take the derivative of? Sorry.
Here's my profit function. I collected like terms. What's 46
Okay.
minus 30?
I got it.
16x, and then the derivative of that will be 16. So no, I skipped a step, which was very naughty of me. This becomes 16x. Sorry about that. Is it Justin?
Yes.
Let me keep that for it. It's your pen. Okay, so everyone cool with the derivative? What?
You said you skipped a step, right?
Yeah, I did. That was my naughty skip step, is I combined 46 and negative 30 to get 16x, and then I took the derivative of that. So that's where that 16 came from. So let's see. This was part A. This was part B. This was part C. Or actually, part B started with stuff on. Okay. Part D. Find marginal profit when 100 units are sold and explain what it predicts. So what do I do, guys? Yeah, it said find marginal profit at 100 units. So I'm literally plugging 100 in for X, and I'm gonna see what happens. 16 minus 0.2 of 100 equals 16 minus 20 equals negative $4. This is not a very big venture, clearly, because if I make a 101st junk muffin, what's happening to my profit. Will decrease overall profits. By $4. So what's happening here, guys, is likely, if this was my profit function, we've got some negative slope. That means we've passed max profit, which should be here, right? So if I have a negative slope, that means I'm over here in this region somewhere. So how do you guys feel about that? My overall profits are probably still positive, but my slope is negative, which means my future trends are decreasing in profit. Does that make sense? There's a difference between negative profit and negative slope. You can have a positive profit and a negative slope. That's this entire region here. Part E, what does it want?
Plug in 101 to the profit,
Yeah.
100 to the profit, and subtract.
Yeah, so P of 101 minus P of 100. We've already got P of 100. That's $500, right? That was $500. So we already did that. So now we just find P of 101. So somebody can do that for me real quick. That'd be great. Does anybody have it yet?
Is it negative 4.2?
Negative 4.2.
Oh, for 101.
Yeah.
Yeah.
You might have gotten the slope. Did you plug it into marginal profit? Yeah.
Just 100.
Oh, sorry, 495.9. So when I subtract 500 from that, what do I get? I get negative 4.1.
100 minus 100.
Really close to what you had, right?
That
Definitely plugged it into marginal profit.
was just an M right there.
Do you see why it makes sense now? Because we're looking at the profit of this particular, all of the first 101 junk muffins minus all of the first 100 junk muffins. And we're trying to calculate the difference between them. And we're gonna lose $4.10. So the real cost of that 101st junk muffin is we're losing $4.10 in profit. And we expected to lose $4 in profit. So this is a really freaking accurate prediction, isn't it? Which is kind of what I told you guys would happen. The derivatives get super accurate as we go along, okay? So we expected loss of $4, we actually lost $4.10. Either way, we went too far, we made too many junk muffins. So what does part F ask us? Yeah, how do we do that? How do we find maximum profit? We set the derivative equal to 0 and we solve for x. And we want the corresponding maximum profit. This is x that gives max profit. Where do we shove that x value?
So the original.
Yeah, because if we want profit, we're gonna shove x into the profit function. If we want a slope, we shove it into marginal profit. Does that make sense? So again, that thing that I do, shove an x into a function, get out a y, shove an x into a derivative, get out a slope, still holds true with these application problems. So we're out of time. I've got to give you guys your homework. I know. I also have, if somebody would do me a huge ass favor, Justin, I'm gonna call on you. Would you mind passing these out? I'm gonna give this to you guys 5 days early, so you can take it home and look at it. This is the review sheet.